This is AP Calculus Lesson 8-1. We're talking about rate equations today. So rate equations are also known as just differential equations. So when I talk about a rate equation, these things measure how fast something is changing. So I'm going to write that out. They measure how fast. And that's the key part. How fast something is changing. All right, so second thing is that it's always going to be, so the units are always I should have just said always units. Always something per time. It's going to be, I don't know what to do for the top. It's going to be something per time.
Something over time?
Yeah. And the third thing is relating it to our previous units. So this is the same as velocity. Or our original f prime from unit 3. So you can think about this as how fast position is changing. How fast position is changing. All right, so we have our first example. So I'm gonna ask someone to read it for us. Thank you, Sophia.
You're welcome.
Did you say yeah?
I said you're welcome. A cylindrical can is used to measure rainfall in Stormville. The can is initially empty and rain enters the can during a 60-day period. The height of water in the can is modeled by the function s, where s of t is measured in milliliters. The rate at which the height of the water is rising in the can is given by s prime of t is equal to 2 sine of 0.03 t. A. Find the rate at which the water height is changing at time t equals 30 indicated units.
All right, does everyone have their calculators?
Carlina.
Carly.
Personal, it's
Can you
not
hand one of these to Carly too?
Can you hand it to me, please?
All right.
Thank you.
So what are we gonna do?
We need to plug in that equation into y equals.
Yeah, we do. So let me open up my calculator. So if I go to my y equals, it's going to be 2 sine of 0.03 t, or x in this case. Okay, so once you have it entered, what do you do?
It wants to find the rate at which the water height is changing. So, does that mean we take the derivative?
So what do you think we're going to be finding here? The rate at which the water height is changing. So S of t is measuring the height, or the position. So is it asking for position, velocity, acceleration? What is it really asking for? Velocity. So what is velocity?
S of t.
No, S of t is height. This is velocity.
So we just plug in 30.
We plug in 30 into that equation. So the way that you can do that is you can graph it in that interval. So it's going to be between a time 30, so let's go window, we'll say from 0 to, I don't know, 40, I guess.
Oh, whoa.
And then zoom 0. All right, if we hit trace and we enter 30 and hit enter, we find that our answer is 1.566.
Isn't there an easier way where you just put in y1 and then in parentheses 30?
I guess it's, if you want to do it this way, so y1 in parentheses 30 like this, that works as well.
Dude, that would have been Oh my god. I never knew that.
1.567 or 1.566. And that's going to be what unit?
Milliliters per second.
It's going to be milliliters, I agree, per time. Per second?
Yeah.
I didn't really specify what T was in here, but yeah, it makes sense to be a day.
Oh yeah, because that's a lot per second.
Yeah, that would be flooding us too much.
Mr. Smell, do you think we're gonna have a major drought again?
Probably.
We're definitely leading to it.
Within the next 1,000 years, I would say yes. All right. So.
I meant
like this next year.
Oh, I'm not sure.
I don't think we're gonna get
Part B. Is the rate of water height change increasing or decreasing?
I was just kidding.
So more to write. We're not writing example 2 because it'll be the end of class by the time we hit part C, roughly. But if you want to get a head start,
So we're writing B?
we are writing B. There's nothing hidden behind the calculator also, so it does end right there.
Is the rate of water height? Oh.
Mm-hmm.
So now we have to find the acceleration.
Exactly, yeah. This is asking for acceleration, and that's because the water height change, this thing right here, is already not V prime. It's, what is our letter that we're using again? It's S prime. So this thing, water height change is S prime, and the rate of S prime is really S double prime.
So we do find that.
Yes. And do we need to find an exact number, or do we really just need to find something else?
We need to find it at 30.
Oh, that's true. S prime, S double prime at 30. But are we looking for an exact number, or just something more general?
Just the sign.
Yeah, just the sign.
Oh, okay.
And to find just the sign, what can I do by looking at my graph?
Just
You
plug
can
it
see
in.
it's positive.
What's positive?
The slope.
Yeah, the slope on our graph is positive. So this thing is greater than 0, it's positive. If you don't like writing greater than 0, you can do a little plus with the circle. That's not universal though. AP graders won't know that that means
Wait,
positive.
I thought S double prime would have been concavity though.
Why is it not concavity?
Because it's the graph of V. Oh, okay, that makes sense.
Yeah.
Oh, that's the third time.
Did you guys see it in the group chat yesterday? Or like the other day? But then you guys didn't. And you're the one
Okay, so this is our rationale for why S double prime of 30 is positive. And now here's our answer. This is the answer that I expect you girls to write on the AP test. So you say that we need rate of the water change, so we have to say that S prime of 30, S prime of 30, and that's going to be increasing or decreasing. What should we write here?
What happened?
Increasing. And then the reasoning is because S double prime of 30 is greater than 0. So in red, that's the answer on the AP test that I'm looking for.
Oh wait, so that's more like, it's not because they have the same sign, it's because acceleration basically is positive.
Yeah, exactly. This is always talking about the acceleration, just like we had on the test that we missed.
Are we doing an example 2 right now, Mr. Smith?
No, we're doing part C after this. What I wanted to do is to copy this graph and put it in my notes.
Okay.
See you later.
Oh wait, I need to write that.
If you want to see the graph in your notes, you can just do a general graph. Because this is S prime of t down here. So then part C, we need to write that as well. So is the water height, and you can do like H2O, I guess is faster than writing water, height increasing, so you can do INC instead of increasing, and decreasing is DEC. So what is the height doing at time equals 30?
It's also increasing
Yeah.
Why?
because
It's still positive,
What's positive?
the height.
Be careful. It's a very specific word that I'm looking for.
the
Slow
velocity.
acceleration.
The rate of change?
Just yell out of enough terms, we'll get one of them correct.
Velocity.
So let's S of 30. I'm doing this in red because this is our AP answer. S of 30. It is increasing, so we can write that.
Because it's above the x-axis.
So that is a reason that I will accept in this class in terms of your verbal reasoning. But what do we write for our AP graders?
Velocity is above the x.
Velocity is greater than 0.
There it is. Velocity is greater than 0, but it's not velocity. What is really what we're going to write here? Because
Height is
30.
using S, somewhere of S.
S
Oh,
prime.
S prime.
S prime of,
T.
not T,
30.
of 30 is greater than 0. Perfect. That's what we're looking for. All right, we have, it's 10:54, so we have 8 minutes left of class. I'm going to go ahead and stop notes temporarily here.